Hello and welcome back to another Digital Foundry developer interview. And this time we're being revisited by a wonderful, super talented dude from id Software. This is Billy Kahn, lead engine programmer on id Tech, and he's here to talk about the latest Doom Eternal stuff. So welcome back, Billy.
Hey, John, thanks for having me. It's always a pleasure to be on here, and you guys do an amazing job with all these videos, so it's an honor to be here. Thank you.
Well, thank you. All right. So yeah, obviously the new patch is out. You've introduced the next generation upgrades, including ray tracing, 120 hertz. The PC also gets DLSS, which is a fantastic inclusion. That's really great. It shows how much support the game has had over the last year, plus all the new DLC and everything. So it's in a great spot. So I guess I kind of want to go through some of the technologies that you've implemented in this, talk about some of your experiences in doing so, and maybe the future of id Tech, stuff like that. So let's get into it.
Sounds great. Let's do it.
So one of the first things is I actually talked to Marty back over a year ago. The last big event that I got to go to was for Doom Eternal, and we did it up in Berlin, and he was there. And I asked, so what's up with ray tracing? And at the time he said, well, the crew's looking into this. We don't really have an exact idea of what we're doing yet, but we definitely have plans for it. Now we know what those plans are. So I guess my first question is what led to doing ray traced reflections, and did you try anything else along the way before settling on this specific feature?
That's a good question. Yeah, well, the question is, why do we do reflections over other topics? I mean, starting off with rendering, every graphics programmer's dream has been, doing this stuff at real time. We've been doing path tracing for the longest time in our light map, and using it for global illumination technology, and so we have a lot of experience with doing that, and a lot of research. Now that we have the hardware capable of doing some of that stuff in real time, when we look at those things, when we want to implement them, it's always about what makes the most sense for the product. Where are we in the life cycle of the product? What makes the most sense? What gives the user, the player, the best bang for buck? Obviously, we always want to run at the highest frame rates, and we want to showcase what the technology can bring and how it adds value to the game itself. So it's not just like, oh, here's a new feature, let's just implement it and hopefully it works out. It's more like, how can we make it so it gives meaning to the player? And reflections was like reflections, like one of the first things when you do path tracing is reflections are key. That's a visual fidelity that you can immediately see. You can see differences there immediately when it comes to, because when you render things, what we do normally, normal rasterization, we usually color that stuff, and our solutions that we currently use, or last gen used, were things like screen space reflections, and those work really well, but they're not as crisp or detailed as you would expect, because we don't have all the information that's required to get the reflection 100% accurate. So things that are off screen, there's no real depth information, things like that. And what we wanted to show something off that the player can immediately see, oh, if I put this side by side, when Digital Foundry makes the side by side videos, can the user actually see those differences? And reflection was the natural thing, because there are also gameplay implications there, such as, what if I come around this hallway and I can see the imp or the mancubus waiting for me? Or how can I figure out my approach? Or just seeing the mayhem as you fire all the projectiles with your weapons, that feedback you get from the reflections and everything shining and stuff like that. That was the key. We wanted to be a showcase of visuals, but also have meaning for the title. That's why we picked that. If you look at other things like shadows, for example, that's a great thing to do, but our game is so fast-paced.
Yeah, I agree there. It's not really, doesn't make a lot of sense, does it?
Yeah, you see the detail with the penumbra, right? You get much better crisp, but if you go on 120 miles an hour, if the Doomslayer slaying demons and glory killing them, it's that fidelity is nice. It's something we're going to research and incorporate, and there was so much content already there. That we wanted to focus and do one thing really well, and reflections was the thing that we thought would give meaning to the game, but also to the visual look, and it was something that players could really enjoy.
Yeah, for sure. And stuff like, I'd imagine, like global illumination, for instance, would have required significantly more work to like make it look right, because it seems like the artist spends so much time already with the lighting scheme and the probes and getting it to look the way it does. So, but thinking of that though, obviously, the artists did go back for this patch, so this isn't just the same old original materials throughout the game, is it? Can you talk about the process and like maybe from their perspective as well, like what this offered for them in terms of revisiting the game and being able to work on those assets again?
For sure, for sure. Yeah, when we the approach we took was not like, okay, let's add this new tech and then crank everything by 20, right, and make it super shiny. Everything is reflective. That wouldn't have looked good, and that was not the intent. We didn't want to break the visual fidelity of the title. We wanted to enhance it. So when we were implementing this, we were in close collaboration with the designers, close collaboration with the artists, and one of the most interesting bits was like we got feedback from our content creators, like from Tony and our art director and Lear, our environment specialist, and on the whole crew that makes the content. Where they're like, some materials we wanted to have them behave this way because when we shipped, we weren't able to do so. SSR didn't give us the results we want, so we toned things down. So when you play Intro, for example, or Hell on Earth, you probably noticed that like there's a wet look on the wood, and that was intentional. Yep. They wanted to get that look, but they weren't able to get that nice sheen on that wood because it's supposed to be somewhat the barge that you're on. They wanted to have that sheen on them. They weren't able to do that. They went like, well, now we have that. They went back and made those adjustments to the materials. But we didn't want to break the original vision of the game. That in balanced mode, you get the original vision of the game, and then ray tracing was like what the artist, how they initially wanted to create it, but the technology wasn't there yet. But now with ray tracing, they could do so. So as you play through the game, some things are not, they're subtle and they give you that extra oomph of fidelity, and some are like more over the top, like in Doom Hunter when you play that and everything is shiny, and you like when you play that first combat sequence, it's like overwhelming how much feedback you get. But it's really really nice, and making it artist driven, not just a technology.
Yeah.
I think gave it more finesse, and that was intentional. That was always by design. So when I see feedback like, when I play the first maps, I don't see much difference. It's like it's meaningful artistic contribution to the title where it makes sense, and giving that control to the content creators to realize their vision. That was the whole goal.
Cool, and that looks great. I guess thinking about the reflections again, then Wolfenstein Youngblood features ray traced reflections as well. Is there any connection there? Did you guys share some of the code there, or is this a completely new implementation?
No, so what we have in patch 6 is our own implementation. Everything was done from the scratch, from the ground up. The reason is because, there's timing. Sure. We weren't available to do that work for Wolfenstein at the time, so there was a partnership with some of our partners that worked on that. And then we want to use that technology moving forward. So it was also like getting the team up to speed, and making sure that what we're already doing in this is something that we can transfer, other titles can use that may use it tech. And moving forward, like just enhancing our code base. So everything's from the ground up. All the implementations are native implementations on all the platforms. So you have Vulkan ray tracing on the PC side, the full KHR implementation of that. We have the native implementation on the PlayStation side where we take full advantage of the lowest level API that's available there, AGC. And then so it's not like a shim layer. We use the lowest as always. And of course, the native DirectX 12 implementation on the Xbox side.
Yeah, that makes perfect sense then, especially if you're looking towards the future to implement it yourselves from the ground up and sort of roll it into id Tech 7 as is. So I get that. Yeah,
there was a lot of learning and making it all. As always, we want to use the lowest level API we can use to get the most out of the hardware we have. We want the product to run the best on everywhere where you play. It doesn't matter what you have. We want the game to play as best as we can, so you can get that Doom visceral experience on whatever you have. And and make that shine.
So that's really cool then. Along those lines, though, you guys, are actually doing something a little different than I think we've ever seen before with ray traced reflections. Specifically, GPU particles seem to be taken into the BVH structure, and I can't think of another game that actually considers GPU particles within the reflection. So can you talk about how that was achieved, and and like, I guess, just your particle system? How are you managing this with ray tracing?
Yeah, we that's it. All goes back to our unified lighting and shading.
Okay.
What that means is all the reflections, like the first pass we did, and this is a little history here. When we first started on ray tracing, we actually replicated all of our rasterization code and did all the same rendering that we would do in the raster path, but all with ray tracing. Obviously, that runs super poorly or really slow, but we wanted to make sure that everything that we rendered in the reflection was 100% accurate. Could we make everything run the same as on the raster path? That was the first test, and that included particles, that included all the opaque stuff that we have. So everything in the environment, all the characters. And once we could toggle between the two, and we were like, okay, all of our lighting equations, all of our shading, all that stuff can be unified, just like we do in the raster path. Then we said, okay, now we're doing the reflections, and we want to retain that shading quality. So when you look at the glass, so if you look at the reflections on the surfaces, the shading we're doing, even to the minute details that we have with the multi-blended, multi-composite materials that we have, and the geodecals that are on the surfaces, all that is retained. We also have, and then for the transparencies, which are one of the hardest problems to get right, SSR cannot, because you don't have the depth information in SSR, you can't really do that well. But because you have the depth, because we're actually, tracing the rays, and we can get that depth information, transparencies, we wanted to see them. I mean, the game is all about particle effects and projectiles flying everywhere and you causing that. We wanted to get that feedback and doing it properly. So all of our CPU and GPU particles reflect properly, and that took quite some time. It took some optimizations to get that right. So one example, if you look at those little blue flasks that we have for the health pickups, you can now see you can see the Doomslayer reflecting in them, and if you have an explosion going off in the background, we even have those showing up in there. So the goal was to really make glass shine. We have a lot of levels that take glass into account, and making that work really well. Yishin and the team, and lots of people, Philip, Thiago, Axel, Jean, everybody worked really hard on making that work properly. Transparencies are some of the hardest things to sort right and get right.
Oh yeah.
We wanted to spearhead that and see if we could get it proper. So when we, for the future, we know how to do that even better.
That's cool. So besides calling some of them from view, are there any other concessions that you make within the BVH to increase performance, especially on consoles?
Yeah, I mean, there's some optimizations, with ray tracing. You have to, we have to make sure all those stuff are being updated. In some cases, the animations weren't fully updated. We need to make those run. There's the way UI works, for example. We have a lot of surfaces that are UI related that are also reflecting properly. Making sure that those don't get turned off when they're far away or off screen, and making that all work, and then rendering it off to an off screen buffer and getting that projection proper so it works right with the reflection was right. One of the things on the particle side, you may notice that the orientation of things in the world when it comes to particles is a very difficult problem. So some of those things don't orient right, and that was a concession we had to make. But the fidelity, that's a minor thing. So you might see some weird orientations in some cases. But the cost of that was too high to make it 100% accurate.
Sure, of course. And honestly, most of the materials in there, there's not that many perfect mirrors, I would say. So
correct.
By and large, when you're actually playing, you don't really notice that anything's off with that. You just see the gist of the particles in the air.
Correct.
Which is really cool. Yeah. So let's see here. But I guess, people are going to want to know, and obviously the ray tracing on consoles is only available on Series X and the PS5. Can you discuss why ray tracing was not feasible on Xbox Series S?
Obviously, we want to hit that. The game is all about fast combat, and we wanted to retain that. We tried it out, and we even for the optimization, We felt that 120 hertz was a better story to tell than ray tracing. There are differences in the hardware.
Sure, yeah. I mean, we were kind of thinking, like on the PC, like Alex was testing an old 2060, for instance. That thing has 6 GB of VRAM, and that thing was like, we had to turn down the texture streaming real low, and it's like, it was clearly with ray tracing enabled, it seems very, very RAM hungry. So I was kind of thinking that maybe the Series S, it's like maybe just a little bit too much, and then you might have to turn down texture detail and stuff like that, which would further compromise the image. And I can understand not wanting to do that. So
it has to add value, right? It just turning it on and be like, now you can't, if it doesn't give you the experience that we want from the title, it didn't make sense.
right. So you're basically saying it's got to kind of meet that minimum requirement. Otherwise, it's like it doesn't make sense to include it.
Right, and like the choice was always like, I want a player to be like in the middle of the game, it'd be like, hey, I'm going in this combat, I'm going to switch to 120 hertz, to get that low input lag. And after that, I'm in the puzzle section of the game. You have a jumping puzzle, and I want to see the cool stuff in the environment. When we switch really quick to ray tracing, or like if you want like the balanced mode, if you want the higher resolution because you just got a brand new 4K TV, and you want to see
Sure.
Super high image quality with the highest resolution possible, then I switch to balance mode, and you can do that all on the fly. I wanted.
I noticed that. That's great.
I wanted players to be like, whatever their fancy is at the moment. The team really wanted to make that a toggleable thing,
Well, it's not just useful for the players; it's useful for us when we do comparisons, because then you can do comparisons anywhere in the world, which we've done. So,
Philip worked really hard on that. He did a good job.
That's good. That's good. Another thing, though, there is a nice feature though that the Xbox, both consoles get, and it's the Tier 2 variable rate shading. And we looked at that. Alex noticed that in the video, and you can sort of see minor artifacts, but ultimately, it's an effective thing. But the reason you would use VRS obviously is performance. So can you talk about like what kind of performance numbers do you get, like using VRS? How much does it shave off the render budget in terms of getting things out? And is that perhaps tied into like how you're able to get, say, the higher resolution on Series X when running the 120 hertz mode?
Yeah, it definitely helps with the performance. I mean, all that stuff is based on heuristics. We use 1x1, 1x2, 2x2 blocks.
Sure.
And one of the benefits it was, and I wish it was available on all platforms, is you would have definitely used it if you had it everywhere.
Yeah, of course.
The notion that we use dynamic resolution scaling. Been using that for a long time, and what we noticed is that, I mean, you have to zoom in really hard. I mean, Alex zoomed in 400%.
Yeah, it was 400%
like,
to see it.
Can
Correct.
I see this? And I was like, well, the game is so fast.
Not normally.
And what makes the most sense? And if I have VRS, I want to use VRS because what it does is it reduces the amount of resolution scaling we have to do on the overall whole frame.
That's what I was thinking.
And it keeps the overall image quality higher. So it made natural sense for us to use VRS to get that to keep. So resolution scaling didn't have to do so much work. There wasn't so much fluctuation going like up and down depending on the load on the GPU. And with VRS, we were able to like have less of that oscillation, and then the overall average image resolution you get from rendering stays higher, and overall that makes for a better image, and that makes more sense for the whole scene, for all aspects of rendering and to the consumer.
Do you have an estimate on like how much that actually shaves off of frame times? Because like if you're trying to hit 120 frames per second, you only have 8.3 milliseconds per frame, right? So like, what kind of savings are we looking at roughly, if you can remember?
Oh, I mean, it was on the 10-15% in some cases.
That's pretty good.
Cases, it's pretty good. It really depends on the scene.
Sure. Yeah.
I mean, if you look at all the platforms we actually shipped 8 platforms. What I say, because there are 3 modes, and 3 modes for Series X, and 3 modes for PS5, and then 2 modes for the Series S. So that's 8 things to test out on. It was quite an endeavor for QA to test and for us to make sure that the quality was the same.
The whole 120 hertz thing then, like last year when it launched in the PC, You guys had people going up to 1,000 frames per second on there. But obviously, you know, hitting 120 hertz on the last gen consoles with those Jaguar CPUs, not going to happen. But I would like to know how your experience was actually reaching that target on the new consoles, because I did test it, and there have been a number of 120 hertz games this generation. But Doom Eternal was so smooth that I actually had a very, very, very difficult time finding even like the tiniest blips in the performance. So I'd love to hear like how your experience was hitting that target on consoles and how you're able to maintain it so consistently.
Well, I think a portion of it is obviously the new hardware, and that the new hardware on all the platforms is fantastic. I'm super happy with the new CPUs, lots more cores, higher clock rate, you know, just better architecture and so on. That's fantastic. But I would also, a large portion of that is also because of the scalability of ITtech. I think we've worked really hard over the years to make sure that whatever you throw, whatever hardware you throw at the engine, it would just take it and be like, thank you very much, I'm going to now run fast. And I think, so I would attribute a lot of it is quite a bit of it is the architecture we have in current place, where we parallelize most of our work on the gameplay side. Pretty much like 99% of the stuff on the rendering, everything is parallelized. That has to be done on the CPU, and then of course the GPU, everything on there is already parallelized. So the ability for ITtech to scale, given to what you have, it was a big contributor to that. And we had to do some, and us focusing on making that really work on the native APIs that we got with the new platforms. Those three things combined, the new hardware, our software, and then of course using the low-level APIs was the key to unlocking that speed and keeping it smooth. There's of course the DRS system that we have, our dynamic resolution scaling, smooths out those hard cases that we have.
Sure,
and you have like lots of particles exploding in your face. And then, you know, VRS helps quite a bit on the Xbox side, you know, on the PC side. VRR is a big thing that also helps. There are a lot of little things that contribute to the overall experience, but a big majority of things is the fact that we spent so many years, the whole team, you know, Thiago, Axel, Johan, Jean, everybody on the team, Oliver, everybody working super hard and making sure that all of our systems are scalable, and if you throw better hardware on it, it just consumes it and utilizes it.
That's cool.
Oliver spent a ton amount of time on the job system to make that really shine, so major kudos to him. And the streaming system he's been working on, it's really awesome.
Oh, that's awesome. It's funny though, you mentioned VRR, and that is actually very useful. But in this case, it's actually not really necessary because the game is hitting 120 anyway. But that actually makes me think, like, how far off are you from being able to actually do 120 with ray tracing on consoles? Because I don't think anybody's done this yet. And at the very least on Xbox, I feel like if there was a mode to just uncap the frame rate with ray tracing, only if you have, like, say, a VRR display, you might actually get something decent. I'm just kind of wondering how far off that would actually be, or if that's even feasible at all.
I mean, we played around with stuff like that all the time. I think it would take more. The numbers have to make sense, right?
Sure,
it has to make sense from the stability standpoint, testing standpoint, and also, like, you know, how many people can play it. I definitely think we need to have more research on that, and I think definitely that's something we can investigate for upcoming things. But, you know, I mean, we make those tests all the time, and people get very excited internally about those things. but there's a difference between implementing a demo of it and then shipping the product so it's stable across the board.
Of course.
And what it's really key, and what we really want, is that we don't want to have those heavy fluctuations. We want the experience to be stable and meaningful and awesome to play for every single level and all encounters, no matter what we throw at it. So if that doesn't pass that filter, and it doesn't make the experience enjoyable for the consumer, we try to we probably don't ship that piece. We do a lot of experiments that like that, and it has to pass muster before we ship something like that.
So that's kind of interesting then. So, you know, last gen you guys were all about pushing 60 FPS with high fidelity. Now the bar's been raised to 120. I mean, do you actually see yourself continuing with this 120 hertz push beyond cross-gen? Like, do you actually think you could do a proper next-gen game and still hit 120?
I mean, if a team wanted to really focus on that, it would definitely be possible. The hardware is there. Just like with last gen, you would have to make concessions of what you want to focus on. The hardware is definitely capable. I mean, we proved it with patch 6. You play the game 120 hertz mode. It's an amazing experience. I've seen comments where people saying, "Oh, wow, I can't go back to 60 anymore," even when they're playing controllers. So that there's definitely something there. Where we're gonna look very very in depth on whether that makes sense for us. It depends. It depends what the goals are. I do think that, I don't think we could only ship with 120 hertz. I think that it would always have to be a 60 hertz mode just so more players can enjoy it. It has to be that.
Oh yeah. You're right. It couldn't be the default. That's true. That wouldn't work. So I guess,
120 hertz mode. I mean, it's definitely something that we'll look at in the future if that makes sense for whatever we do next.
I guess this kind of split makes sense actually, having like fidelity with ray tracing at 60 hertz, and then like here's the high frame rate mode for those that prefer that. So
yeah, there's precedent for that too. If you look at 2016 or even Eternal, we always try to give players choice. Look at all our settings we expose. The goal is to make the experience something that the user can customize to their liking, and I don't think this has to be any different here. So if there's a possibility for do that, we'll try to aim for that. I can't guarantee that whether that's going to be the case, but we always try to make. I mean, we offered FOV changes ever since 2016, and we continue doing so here. So just we'll try to do our best to give you as many choices as we can to make the experience a good one.
That's interesting, actually, because you're right. The Doom, especially Doom Eternal, you guys really doubled down on giving settings to the user, like an insane number of settings. So I assume then that's been well received then in the community. People like that, right?
Well, yeah. I mean, like
I do.
I personally enjoy it, so maybe it's a little bit. I know a lot of folks out there enjoy it as well, because there's always something about like I like the whole game, but there's this one thing that I may not like, and then allowing the user to tweak that, just adds value to the product. Replayability, it adds fidelity. Also, I mean, accessibility is a huge topic that we, as in the industry, need to focus on. It's super critical. It's something dear to my heart that's very important to me personally. That we do better on that. So all those features that we add are on that trend. We wanna make it so the more players can play the game the way they like it, so they can enjoy the title. We don't want to be giving that option is a positive for us.
Definitely, I'm glad to hear that. I'd like to see that continue because options are awesome. I especially love all those visual modes you guys include in there. Like, some of them are cool, like cinematic and whatever, but then you have the really crazy ones like the classic Doom with the low color palette and the Game Boy one and stuff like that. It's fun. That's good stuff. But another option that you guys added, actually, we should talk about this as well. So the PC version got DLSS. And I'm interested to hear from your perspective how it was implementing DLSS into id Tech 7. Yeah, because it works really well.
I mean, deep learning is a big topic. I think we're going to see more of that in the future. I mean, NVIDIA's DLSS, as you can see, yielded good results. Usually, we favor things that we have full control over, that we can tweak on, so we can support it better for the public and for our players. But in this sense, it made good sense because it gave us such good results, especially since it now works with resolution scaling. If you guys noticed that.
Yeah, that's right. That's kind of a new thing, isn't it? Like that's something we really haven't seen is DLSS with dynamic resolution scaling. That's really cool. Like, can you talk about actually how that implementation works, roughly?
Well, obviously we give DLSS some information,
right,
in a texture format, and then it uses that to. There were some heuristics that they had to play around with, and we worked very closely with NVIDIA on that. I don't think I can talk about the proprietary nature too much, but it was a collaboration between NVIDIA and us, and it was important that we were involved in that so we could It was a good experience, and that you can turn it on and off, and you can see. I mean, the game already runs so fast.
Yeah.
If you turn it off, I mean, most folks probably have high frame rates on their rig already. So adding DLSS was just like, okay, well, if you're just on the cusp, on the edge of like hitting that 144 hertz, or if you have a rig that is running the game really well, but you haven't reached that target yet, just slightly, and maybe that gives you the extra boost without too much sacrifice. So it was a natural addition to us, and it made sense for us to add. For people to give for players to be able to tweak their settings just the way they like it to get that look they want.
Oh, it's especially great for some of the older and slower Turing cards, like the first generation of ray tracing cards, because with that you can actually get really high frame rates without turning off ray tracing. So
correct.
And still the image quality looks great. So that's a nice bonus for sure.
Okay. I mean, and we looked at our our anti-aliasing solution, Tiago's TSAA looks really, really good.
Yeah, it does.
And it works really well. So, and then we were like, let's compare it to Tiago's TSAA and make sure it runs and performs, and the results are really good and gave us a nice boost. But machine learning and deep learning and using those technologies even for other pieces of rendering will be the thing that we'll be investigating down the line and have plans for. So just it is where we're going, and adding it was just one of those things we felt that was the right choice.
Yeah, I think that's actually something everyone watching should keep an eye on. And you're not the first to say this. A lot of developers we've talked to, there's a lot of talk about this machine learning right now. So I'm very excited to see where this goes in the next few years, because obviously we're still in the infancy of it as far as game applications are concerned, but very promising, and not just for image quality necessarily. So, there's a lot of potential there. So I'm really excited to see that. But thinking about the future, I mean, like Intech 7 right now seems to be in a really solid spot. I mean, it's been shipped on so many platforms. It's running like super fast. Like, how are you feeling about it right now, just in general, and your technology base? Especially if you look back at like where you guys came from, like the lead up to Doom 2016, that's out. Now you got Doom Eternal out. Like, it just feels like so many strides have been made.
Yeah, thank you. I mean, the team, everybody on the team worked really hard. And it's not just the engine team. It was, gameplay and art and design and production. Everybody worked together to achieve this goal. It's not just code that makes this all happen. It has to be a collaboration with the content creators to make pragmatic choices on how we create the content and where we focus on quality on, and where we make some concessions on. So it's a cohesive thing. I mean, major kudos to the entire team on the program side for sure. The list goes on and on. Oliver, Jean, Axel, Tiago, Ishan. I mean, Philip. I can just rattle off hundreds of people. But one thing to remember is we're a pretty small crew of developers. Our team is fairly small.
Yeah, that's right.
And that gives us. I mean, we don't have 500 programmers, and we try to make choices that enhance the product rather than just implementing things. They always have to add meaning to the title. So we talk very closely with the artists and the designers to make those choices that make sense. Where do we focus? What do you focus on, and take one thing and really make that stand out feature. And always the high frame rate is very dear to us. I think we accomplished all those goals, and we continue working on that. There's lots of work to be done here that we can improve upon. So we can't. It's always those moments are fleeting. We can't. Everyone's doing fantastic work out there, and we learn from everyone out there that's doing great work, and we're all fans of all those games. So we appreciate the kudos, but there's tons more work to be done.
Yeah, and I'm eager to see where it goes next, because I can imagine you guys are hard at work on something else right now, and in this early phase, it's probably a lot of fun poking around with new technologies and all that. And we already talked about machine learning, but is there actually anything else that's like where you're like keeping an eye on the tech and you're kind of excited to play with?
I mean, obviously, ray tracing has a lot of applications that we want to use that are not just reflections.
Sure.
We're going to look into obviously the things that are out there already. How can we incorporate, or how can we improve global illumination? what does it mean for our shadows? How do we incorporate a whole product that may use that? Where can we use it for other things? Like, there are lots of, I have some ideas, and the team has some ideas on how we want to approach it for culling.
Oh yeah, interesting.
And then how can we leverage it for gameplay opportunities? But we're just in the first early stages. It's hard to see how that all shakes out. It's like if you look back in the day when we first got our shaders, shader 1.0, and then look at what we have now. I would equate what we do with ray tracing still in those early phases. We were all excited and we were trying things out, but it took a few years, and then once we all figured out how to make it shine, and all these great things came about. And I think the same thing happened here. We've all been dreaming about ray tracing for the longest time, and now that we have it, I mean, all the papers that we read from the 70s, 80s, 90s, 2000s that have been around for so long, can we implement some of those and make those work in real time, and how do those things work? So ray tracing, obviously a big thing. Machine learning, deep learning, how can we leverage that for temporal solutions? How can we train our data? I mean, I can envision things like, imagine playing a game where an AI, again, I'm not saying we're doing this, but
no, it's fine.
Spitballing here, where you imagine you play Doom and the AI learns how you play, and then the AI is suddenly learn how to counteract some of the movements you do as a natural progression to difficulty.
Sure.
So I mean, there could be like, maybe you're the data set where your gameplay all of a sudden and then it adjusts dynamically. Maybe it becomes a little easier, or maybe it becomes super hard. If you choose to play that way, there are lots of opportunities away. Or like, how do we take those temporal solutions we use now on the visual side, and how can we train those? I mean, DLSS is a great example where deep learning has made great strides. There are lots of different ways we can use that.
You could really supercharge a Marauder with some deep learning, I think.
Yes, the Marauder.
Hunt you down throughout the
Marauder
whole
3.0.
That would be great. It's interesting that ray tracing is now a real thing, especially in the console space. I mean, do you guys remember when you first heard, like, oh, hey, there's going to be ray tracing in these new consoles? I mean, did you even expect that, or was this just kind of a pleasant surprise for the team?
I mean, we have really close relationships with a lot of partners.
Of course, yeah.
And those things are planned out many years in advance, so we kind of knew what was coming. And we actually had in our roadmap to work on these things, and we all have a lot of experience already with path tracing and things of that nature, just from the light map work and other areas. So it wasn't like, oh, on Tuesday I came in and boom, here we have this card now. It wasn't like that.
Yeah.
It was something we knew was coming, and we gave some feedback. We gave feedback on the API structure and things like that nature, But there's difference talking about it and then getting your hands dirty and working on something. And
sure.
Patch 6 was really when we were able to spend a lot of time on it and make it work. A demo is always different from shipping a product.
Big time, absolutely.
And shipping was a necessary step that we felt that was required to really make sure that this was a solid thing. And so it's a long process. We always plan 5-7 years in advance.
All right. And well, I'll certainly be curious to see where we are in those 7 years from now. So that's good stuff. So before we head off here, maybe I want to give you a chance to talk about, is there any particular feature or technology that you guys implemented in id Tech 7 for this game where you look back on it now, having basically reached the finish line, and you're like, man, I'm really glad we did this. This was really awesome. I'm really proud of this. Like, anything you want to highlight?
Oh, wow. There's so many good things to highlight. I mean, Oliver's work on the job system, the refinements we did on the job system and the streaming is some major leaps and bounds. The resources, the amount of data we're pushing through the pipe, and the amount of flexibility we have from those two systems alone is huge. I would say the visual fidelity on some of the things like the water that Ishin and Tiago worked on, and that you saw realized in the Ancient Guards Part 1 and the oil rig on Atlantica. I mean, those look really nice. The geom caches
Oh
huge
yeah.
progress on those. The geocache is such a great way of getting fidelity in the world, make it feel alive,
Yep.
and
Yep.
have those, and the way you can create content is huge. If you like the gore nest when it explodes, or when Atlantica explodes, when the oil rig falls down, all those are geocaches, for example. And just Axel did an amazing work on the geocaches.
I agree. Yeah.
Jean and Bogdan and working on the particles, the GPU particles, and how the effects play out. Effects play a huge factor when it comes to the game.
Sure.
So making those run really well and fast. Um, they're the list can go on and on. I mean, the geo decals. I don't know if you guys. I don't know if we talked about those.
Yeah, they were in that original video that we did. You guys
Yeah.
helped me out with the tool stuff. We showed that off. It was really cool.
Yeah, the geo decals are a huge way of reducing the amount of texture fidelity you have to have. So rather than burning the normal map information or some of that fidelity into the textures, the geo decals that are burned into the surface make it really quick for artists to create, make adjustments to content without having to rebake their assets. And even better, it reduces our texture sizes massively, right?
That's
so you
awesome.
don't. So that's a huge factor. We're going to continue doing so. And overall, the architecture of the unified lighting and shading, so that everything is lit the same way, and having that small number of shaders so we can run really fast, allows us to pivot really quickly, and add features. I mean, there's multi-composite materials. I mean, there's a huge list of things that I think we can draw on, and I'd probably bore people to death speaking for another hour or two just on the feature set. But the whole team, and it all comes down to collaboration, and making a title like Doom Eternal requires buy-in from all the departments and alignment, and that alignment allows us to shine. It's not just one group. It's programming, art, design, audio, production, all working together towards a common goal. And that's really the especially with a very small team, comparatively speaking,
Yeah.
to eat in that space.
Well, I think the results bear themselves out when you play the game. We're certainly impressed with it. So
Thank you.
thank you for all your hard work on that, because it's an awesome looking game, great game, and yeah. So and also, of course, thank you for joining us again.
Thanks so much, John. Appreciate you, and thanks for all the hard work on all those videos. We're all big fans. We love watching
Thanks.
those. And yeah, major kudos to Alex's video as well. That was very insightful.
That's good.
Thank
yeah.
you so much.
I will definitely share that with him, or he'll see it in
Yep.
this one. And I'm sure we'll have you back in however many years it is, until when the next game ships, whatever it is. We would love
Yeah.
to have you back and do this again. So
Thank you. Happy to chat anytime.
look forward to that some years down the road. But if you guys enjoyed this video, of course, as always, be sure to follow us on Twitter, like, subscribe, all that kind of good stuff. And of course, go check out Doom Eternal if you haven't. It is an awesome game. But that's going to do it for us. So until next time, thanks for watching.